So moving on to question 3 now from Edexcel's June 2018 paper 1, and this is a quick question on arc sectors here. We're given a bit of information. We have centre O here and radius r centimetres, and the angle AOB is theta radians and the area of the sector AOB is 11 centimetres squared. So we're given that the perimeter of the sector is 4 times the length of the arc AB, and we have to find the exact value of r. So we have to take a step-by-step approach. So let's use some of the information that we've been given so far. So straight away, we know the area of the sector AOB is 11 centimetres squared. So we're in radians here. So we know the area, so that's half times theta times r squared. So r squared theta. And we know the area is equal to 11 centimetres. So this is equal to 11. So that's the first bit of information we know. We also know that the perimeter of the sector is 4 times the length of the arc AB. So knowing this information, let's work out the perimeter. So this is going to be r plus r, so 2r plus r theta. And that is going to be equal to 4 times the length of the arc AB. So this is the extra bit here. So that's r theta, so it's going to be 4r theta. 4r theta. Now, we have 2 pieces of information which we've assigned into equations. Now we just have to do a bit of substitution to get here. And there's a couple of ways you can do it. What I'm going to do is I'm going to get this top equation here in terms of theta and substitute it back into this here. So half r squared theta is equal to 11. So I want it to be theta equals. Well, first let's divide by the half. So we'd have r squared theta, which would be equal to 11 divided by half. So remember, if you divide by a half, you have calculators anyway for these papers, so don't worry about figuring anything out like this in your head. But if we divide by half, it's the same as times it by 2, so that'd be 22, and then we divide by r squared. So theta is equal to 22 divided by r squared. We know that just by rearranging this to be in terms of theta. Now what we're going to do is we're going to sub it back into this equation here. So 2r plus r theta. So all I'm going to do is I'm just going to write it out first and then we'll simplify next. So 22 divided by r squared is equal to 4r times theta. So 4r times 22 divided by r squared. So now we can simplify. So the 2r won't change, so it's going to be equal to 2r. Now if we've got r lots of this, what's going to happen is this r here will cancel with one of the r's here, so that power of 2 will just go down to a power of 1, so that's 22 over r, so plus 22 over r. And then this is going to be equal to 4r times 22 divided by r squared. So again, this r will cancel with the power of 2 to give me a power of 1 here. So this is 4 times 22 over r. So that's going to be 22, 44, 66, 88 over r. Like that. Now what I can do is times through by r. So this will get it in terms of a quadratic. So this will be 2r squared plus 22. And that's going to be equal to 88. And now what I can do is just solve this quadratic here. So it's 2r squared plus 22 is equal to 88. So I can take this 22 across. So it's going to be 2r squared is equal to 66. Now we can divide through by 2 to get it as just r squared. So r squared is equal to 66 divided by 2. So that's going to be 33. And therefore r must just be the square root of 33. Remember, we can only have the positive square root here because we're dealing with lengths, so we can't have a negative value, it doesn't technically make sense. So the square root of 33 is just our final answer. And there we go, there we have it.